Okay, 5.4, equilateral and isosceles triangles. We have the base angles theorem, and that just says if you have an isosceles triangle, then your angles have to be congruent. Now, not this angle between them, not that one, okay? And then you have the converse to the base angles theorem. If you have the base angles, okay, then you can say you have an isosceles triangle, okay? And again, not the side between them. All right, corollary to the base angles theorem and corollary to the converse of the base angles theorem just means if it's equiangular, it's equilateral. If it's equilateral, then it's equiangular. Let's get at it. All right, so complete the statement. If AE, so we're going to mark this, AE is congruent to DE, then the opposite angles, the base angles theorem, these have to be congruent. So angle A and angle D. Now there's only one vertex at those points, so we can use one letter. Okay, now let's do blue here. AB is this one right here, and we'll use two marks. AB and EB. All right, then that means these two angles are congruent. Remember, not the one in between them. So angle A again, and then angle AEB. You need three letters for that one. Okay, and I guess you didn't have to do number two. Number three, if angle D, let's just erase all of that stuff there. If angle D, angle D is congruent to CED, then that means not the side in between them, but the other two sides are congruent to each other. So EC and DC. And for practice, number four, EBC. Let's go ahead and erase those. EBC, angle EBC, and ECB are congruent. And again, not the side in between them, but the other two sides have to be congruent. So EB and EC. All right. Number five, find the value of x. Well, it's equiangular, so it's also equilateral. So x equals 12. All the sides are the same in an equiangular triangle. That's the corollary to the base angle theorem. Okay? Now, number seven, all the sides are the same, and this is the angle. Notice it has the degree symbol there, so be careful. That's not talking about the side. It's talking about the degree. In an equilateral triangle, you have an equiangular triangle. So all three angles are the same. And the triangle sum theorem says that all angles add up to 180. So if they all add up to 180 and divide it by 3, each of them has to be 60 degrees, which means x plus 8 has to equal 60 degrees. So subtract the 8, and x equals 52. 11. Find the values of x. Okay, so x and y. Okay, so let's first start with x. Notice that we have all three sides of this middle triangle the same. So that means it's equiangular, which means all three sides have to be 60. So x is equal to 60. Okay? And then to get y, notice we have parallel lines here. So you got two parallel lines. And you have a few ways you can go about this. Remember, this is 60. And all these sides are the same here. All right, so that means if those two sides are the same and these two sides are the same, we need to know about these angles here. Now, that doesn't mean those two angles are necessarily the same, okay? Now, we do have the fact that you have a transversal right here. So this angle and this angle are alternate interior angles. Well, we already know that's 60 degrees, so that means this must be 60. And if all of this right here is 120 degrees, and all the way over is 180, that means that angle right there has to be 60 degrees as well. And the base angles theorem says that the two angles have to be the same. So y has to be 60 as well. All right, find the values of x and y again. Now these are just puzzles. Again, you see equiangular, which means these are all 60 degrees, okay? and this is a straight line. A straight line is 180, so that means this must be 120. And on this triangle right here, equal angular means equilateral as well. So that means the 8y and the 40 have to be equal. 8y equals 40. Divide off the 8, and y equals 5. Okay? Which means if each side is 40, that means this piece right here is 40. Well, and the other side's 40. So that means those two are the same. And this is a base angles theorem, which says that angle x is the same as this angle. And if they're both the same, there's 180 degrees in each triangle. So 180 minus that 120 is 60 to be divided evenly between those two. So x has to be 30 degrees. Okay. 15, modeling in real life. All right, so we have an equilateral triangle here. Find the values of x and y. So base angles theorem says these two angles have to be the same. So x is 79. And there's 180 degrees, triangle sum theorem in the triangle. So 79 plus 79 is 158. And subtract that from 180. You get 22. So y has to be 22 degrees. 17, describe and correct the error. All right. So first of all, what do we see here? I see the converse to the base angles theorem. The converse to the base angles theorem says if you have the angles that are the same, then that means the opposite two sides have to be the same. So that has to be 5, and that has to be 5. All right. Now, describe and correct the error in finding the length of BC. Well, we just found BC. BC has to equal 5. Notice I didn't put a symbol above it because I'm talking about the distance. It says that AC and BC are congruent, which, yes, that's true. And angle A and angle C are congruent. Yes, that was given. So that's the part they did wrong. All right. Okay, so now we're modeling in real life. I'm going to try to draw this out here to make it look a little better. Let's see what it says here. The diagram represents part of the exterior of the bow tower, or bow tower, in Calgary, Alberta, Canada. In the diagram, ABD and CBD are congruent. All right, so it says they're congruent. So I'm going to draw it kind of. I'm going to do it the way it would look if you were looking straight at it. It has a bend in the picture. So it says A, B, D, and CBD are congruent to each other. So I didn't draw that very well. Let me redraw real quick. Okay, that's better. Now those two, the top triangle and the bottom triangle, the bigger triangles, are congruent to each other. All right, now, part A. Explain why ABC is isosceles. Okay. Let's see here. Okay, so if the top triangle, the big triangle, and this big triangle are congruent to each other, that means that this full angle here is congruent to that full angle. And this is an angle bisector here, which means this angle is congruent to this angle. Okay? And the base angles theorem says, let's draw the triangle here. We're talking about ABD here now. ABC, excuse me. So this angle and this top angle here. So that means that side and that side have to be the same. That's the base angles, the converse to the base angles theorem. If you have your base angles congruent, then the opposite two sides are congruent, making it isosceles. All right, so that was part A. Part B, explain why BAE, oh, E is in the middle here. BAE is congruent to BCE. Okay, so BAE, we're talking about that one and this one again. Well, we just explained that. Okay, you have these angle bisector here. This is a perpendicular line. All right. And if they're congruent, then that means this is congruent, and that's an angle bisector going through the midpoint and touching a vertex. That's why it's an angle bisector. C, show that ABE ABE, and CBE are congruent. All right, so what we're looking at, I'll draw it in blue this time, ABE and CBE, the bottom one here. Well, we know that that angle and this angle are congruent. We know this angle is congruent. It's 90 degrees. Okay. We also know that these two are congruent from part A. And let's see here. So we haven't taught angle, angle, side yet, or hypotenuse, leg. And one thing I forgot to make sure we understood is you have an equilateral triangle, the top triangle and the bottom triangle. So all those are the same. And because of that, that angle and that angle are equal, and because of these two angles, the corollary, converse of the base angles theorem. So what we have is also BE being congruent to itself. That's a reflexive property. Okay. And so you have side, angle, side to make both ABE and CBE congruent to each other. So that's part C, side, angle, side. Okay. Find the measure of BAE. BAE. Angle BAE. All right. So let's pull this out just a little bit here. It's an equilateral triangle. So BAE, this whole thing here has to be 60, and this is an angle bisector, so that's 30 degrees. All right, let's go on. Find the perimeter of the triangle. All right. Notice we have the converse of the base angles theorem. If you have the base angles, then these two are equal to each other. So x plus 4 has to be equal to 4x plus 1. So I'm going to subtract x. Get 4 equals 3x plus 1. Subtract 1. Divide off the 3. I apologize, I have a cold. X equals 1. So if x equals 1, that's not the answer. It wants the perimeter. So we have 7 plus, let's plug 1 in for x here. 1 plus 4 is 5. And plug the 1 in there. 4 times 1 is 4, plus 1 is 5 again. Well, they're supposed to be the same, remember? It's an isosceles triangle. So 10, that's 17 inches. That's your perimeter. Okay, reflexive property means it's the exact same thing. So SE is congruent to SE. Symmetric property, if that's how we started, then you just reverse it. If JK is congruent to RS, then RS is congruent to JK. Transitive property, beginning is to middle, middle is to the end, so the beginning is to the end. Okay, good. And find the measure of angle 1. This is the exterior angles theorem. So the exterior angle equals the opposite two angles added together, 8x plus 79. All right, so subtract 8x, and you get 12x plus 7 equals 79. Subtract 7, and 12x is equal to 72. Divide off the 12, and x equals 6. So that's not the answer. Find the measure of angle 1. Angle 1 is right there. So if x is 6, 20 times 6 is 120, plus 7 is 127. And this is 180 degrees. 180 minus 127 is 53 degrees. So that's the measure of angle 1. That's the answer. And last problem, mean, median, mode, range, and standard deviation. All right, so we're going to skip the standard deviation for right now. Mean means the average, so add them all together. Let's figure out what that is real quickly. So I'm going to go 10, 20, 30, 40, 50, 60, 63, 71, 78, 81, 86, 90. And then divide by how many we have. 1, 2, 3, 4, 5, 6. And that would be 15. So our average, or our mean, that's the symbol for mean, is 15. Median is the middle number, so you have to put them in order. So we have 13, 13, 14, 15, and then we have 17 and 18. And we got them all, so there are 1, 2, 3, 4, 5, 6 numbers. So 1, 2, 3, 1, 2, 3, so it splits there. So 14.5 is the median, halfway in between those two middle numbers. And the mode is the most frequently used, which would be 13. 13 is used twice. And the range. The range is you take the bigger number minus the smaller number, and that is 6. And we'll talk about standard deviation later on this year. Good job. And there are all your answers, just in case you were wondering.